Welcome to Maths with Jade. In this video tutorial, we will be doing the equation of a straight line, which hopefully you all should know is y equals mx plus c. Although I will be recapping the basics of y equals mx plus c, this video will get quite technical and quite algebraic, so if you're a beginner, this might not be the video for you. So y equals mx plus c. The m stands for the gradient, which in other words is how steep the line is. And we calculate it by finding the change in y and dividing it by the change in x. I recommend writing this down if you don't already know this, it's very, very important. And the c stands for the y-intercept, which is where the line cuts the y-axis. So let's look at an example. Here is a straight line and I want to find the equation. Well, first, to find the gradient, pick 2 points on the line. Now, it doesn't matter what points you pick, but I'm going to choose 2 points that have nice round numbers. And now I'm going to draw a triangle. And I'm going to calculate the distance we've travelled along the x-axis. Well, we've gone from 0 to 1, which is a distance of positive 1. And then I've gone from 3 to 5, which is a distance of positive 2. Now, to find m, I can just do 2, which is the change in y, over 1, which is the change in x. This simplifies to 2. And now to find the y-intercept, I'm going to trace my pencil across the y-axis until I meet the line. And I meet the line at 3. So my y-intercept c is equal to 3. So if I know my value of m and my value of c, then I can just replace them and say that the equation of this straight line is y equals 2x plus 3. Great. Now let's look at a different example. Here's a straight line, and I'm going to pick 2 points on this straight line. So I'm going to go for 2, 1, this one right here, and I'm also going to go for 4, 3. Now you might pick points closer together, and I recommend you do that. However, I want to prove a point to you that it doesn't matter which points you pick. Now my x distance, I've gone from 2 to 4, which is 2, and then I've gone from 1 to 3, which is 2. So my gradient m is 2 over 2, which simplifies to 1. You will get this answer no matter what points you pick. And now I'm going to see where the line cuts the y-axis, and it cuts at -1. So c is equal to -1. So if I have the value of m and I have the value of c, then I know the equation of this straight line, which is this. However, we would never write 1x, so we'll leave the answer as y equals x minus 1. Now a slightly harder example. Here is our straight line, and we want to find the gradient. So I'm going to pick 2 points on the line. I'm going to pick this one and this one. They're quite obvious choices actually. And now I'm going to draw a triangle, and my change in x, I've gone from 0 to 1, which is 1. But my y distance, I've gone from 4 to 0, so it's -4, which means my change in y is -4. My change in x is 1, which means my gradient is -4. And it should be quite easy to find the y-intercept. It's one of our points we picked, and it is 4. So c is equal to 4. Now we can just replace m and c with the values that we know into y equals mx plus c, and we get y is equal to -4x plus 4. One final example then before you have a go. So here is our line, and I want to first find the gradient. There's less options for points to pick on this one. Try and pick ones with nice round numbers. Draw your triangle. I go from -3 to 3 on the x-axis, so that's a change of 6. And I go from 2 to -2 on the y-axis, which is a change of -4. So -4 over 6 can simplify to -2/3. And that is my gradient. And the line crosses at 0. So c is equal to 0. So I know m, I know c, I know the equation of my straight line. It is y equals -2 over 3x plus 0. But we don't need to write the plus 0 for obvious reasons. So your turn then. Find the equations of the following lines in the form y equals mx plus c. A little word of warning, do check your axes and don't just find the gradient by counting the squares. Pause the video now. Here are the correct equations for those straight lines. If you made a mistake on question 3 or 5, then just go back and check carefully the axes. What if we remove the graph entirely and take a more algebraic approach? So I want to find the gradient and y-intercept of the following line. I have y equals minus 2x minus 7. I'm going to compare this to y equals mx plus c, and I can see that the m is the number in front of the x, so in this case, minus 2. And then the c is the number on its own, in this case, minus 7, and I have found my gradient and y-intercept. Let's mix things up just a little bit. What if I want to find the gradient and y-intercept of this line? Well, to identify the gradient and y-intercept, we need it in the form y equals mx plus c. So we're going to rearrange to make y the subject. You should be quite good at doing this if you're at this stage of algebra. So we're going to subtract 4 from both sides, which eliminates it from the left-hand side, and I'm left with this. And now I'm just going to add 3x to both sides. That eliminates it from the left-hand side, and I'm left with 3x minus 4 on the right-hand side, and y is the subject. And now I can easily identify that 3 is our gradient and minus 4 is our y-intercept. One more example of this then. So I have something which is not in the form y equals mx plus c, so I'm going to rearrange to make y the subject. So I'm going to add 6 to both sides to eliminate it from the left-hand side, and I'm left with this. Now I'm going to divide everything by 3, every single term, which eliminates the 3 in front of the minus y. And I have 2/3 of x, and that 6 divided by 3 just becomes plus 2. And now I don't want negative y, so I'm going to multiply by negative 1, which is essentially changing the sign of every term. So my negative y becomes positive y, and I'm left with minus 2 over 3x minus 2. Now I can identify the gradient and y-intercept. Okay, it's your turn then. Find the gradient and y-intercept of the following lines. Pause the video now. So that should have been quite straightforward. Here are your solutions. You should now be pretty happy with y equals mx plus c. So let's look at finding the equation of a line given the gradient and a point on that line. So here's an example. The gradient of a line is 5 and the coordinates 2, 7 lies on the line, and we want to find the equation. Well, we know the equation of a straight line is y equals mx plus c, and I'm told immediately what the gradient is, so I can replace m with the known gradient, in this case 5. But I still have the problem of finding c. But I'm told that 2, 7 lies on the line, so we know that when x is 2, y is 7. So I can use this to find c. So I'm going to substitute in the coordinates of that given point. So my y becomes 7 and my x becomes 2, and I'm left with 7 is equal to 10 plus c. And now I can just solve to get c on its own. So I'm going to minus 10 from both sides, and I'm left with my value of c, which is minus 3. And now I can just replace c in my y equals mx plus c with my minus 3, and I've got my equation. Now for a second example. The gradient of a line is minus 2 and the point with coordinates 4, minus 1 lies on the line. What is the equation of the line? Well, first we can start with y equals mx plus c and immediately replace m with the known gradient, in this case minus 2. So y is equal to minus 2x plus c. Now looking at our coordinate that we're given, we know when x is 4, y is minus 1. So we're going to use this to find c by substituting in the coordinates of that given point. So y becomes minus 1 and x is 4. We can simplify that a bit. Minus 1 is equal to minus 8 plus c. And now I'm going to solve to find c. I'm going to plus 8 to both sides to get c on its own on the right hand side. Minus 1 plus 8 becomes 7 on the left hand side. And now I've found my value of c, so I can just put that into my equation with my known gradient minus 2. And I end up with y equals minus 2x plus 7. Your turn then. Find the equations of the following straight lines. Pause the video now. For your solutions, check your answers carefully. And finally, for this tutorial, I want to look at finding the equation of a line given just 2 points on that line. Here's an example. A line passes through the points with coordinates 3, 2 and 5, 8, and we want to find the equation. Well, if I look at y equals mx plus c, I don't have m and I don't have c, so I need to find both of these. Now we could find our gradient by looking at our points and plotting them roughly. So I have 3, 2 and I have 5, 8, and I have a straight line going between them. Well, we know from the beginning how to find the gradient of this. So let's look at my change in x. Well, that's going from 3 to 5 is 2, and then I go from 2 to 8, which is 6. So my gradient is 6 over 2, which is equal to 3. Great. However, we don't want to plot this every single time. So I'm going to give you a formula for the gradient. If I have 2 points on a line, I'm going to call the first point x1, y1, and the second point x2, y2. Then the gradient is the second y coordinate minus the first y coordinate, all over the second x coordinate minus the first x coordinate. And this will work every single time without the need to draw a graph, so please write this down. Essentially, all I'm doing is finding the change in the y and dividing it by the change in the x. Let's see how this works in our example. So label your points x1, y1 and x2, y2. And our gradient is equal to y2, which is 8, minus y1, which is 2. And then that's all over 5, my x2, minus 3, my x1. That simplifies to 6 over 2, which is 3. So now I can replace my m with 3, and I'm left with y equals 3x plus c. Now I'm going to look at one of my coordinates, and we know x is equal to 3 when y is 2. So I'm going to use this to find c. You could have used the 5, 8 coordinate. It's really up to you. I like to pick the coordinates with smaller numbers. So I'm going to substitute that in, and I get 2 is equal to 3 times 3 plus c. That simplifies to 2 equals 9 plus c. And then I'm going to solve to find c. Minus 9 from both sides, and c is equal to minus 7. Put that into my y equals mx plus c, and I've found the equation of my straight line. For my second example, I want you to get used to putting negative numbers into that formula for the gradient. So we know y is equal to mx plus c. I'm going to start by finding m by looking at these two coordinates. Label the first one x1, y1 and the second one x2, y2. And now we simply substitute in. So m is equal to 10 minus 4 all over minus 1 minus 7. It's really important here that you don't drop negative signs. A minus and a minus make a plus. So we end up with 10 minus 4, which is 6, and minus 1 plus 7, which is 6. So that simplifies to 1. And you should all be experts by now on what to do next. We know what m is. It's 1, so replace m with that gradient. I don't need to write the 1, obviously. And now to find c, I'm going to choose one of my coordinates. It really doesn't matter which ones we choose. I'm going to choose minus 1 and 10 and use that to find c. So I'm going to substitute in the coordinates of that given point, and I get 10 is equal to minus 1 plus c, plus 1 to both sides, and c is 11. I have found my straight line. It is y equals x plus 11. And we are almost done, guys. One final activity. Find the gradient of the lines between the following points for question 1. And for question 2, find the equation of the following lines given 2 points on those lines. Pause the video now. Here are your solutions. Thank you for watching. This has been a very long video tutorial on the equation of a straight line and y equals mx plus c. This has been Maths with Jade. If you liked this video, please do hit the like button. It really helps me out. Subscribe to my channel, share this video, and all comments are welcome. See you next time.